Hello and welcome to Audible River. I'm Alan Rice, and I am very happy to have with me natural philosopher Michael Alan Prestwood. Michael is also an author whose most recent book is called 30 Philosophers, A New Look at Timeless Ideas. Michael is the creator of touchstonetruth.com, where you can find many engaging articles on philosophy, science, critical thinking, and history. Hi, Michael. It's great to see you today.
Thanks, Alan. It's wonderful to be back.
Yes. You know, I'm really impressed with your website, touchstonetruth.com. And one of the things is that you have a lot of really good science articles that is digestible in a way that people can understand complex ideas that are, we know about, but you've explained it in a way that, most people can grasp what the science is behind it. And the thing I wanted to talk to you about today is quantum mechanics. I see you've got some mention on your website about it, but just briefly, what is quantum mechanics?
Quantum mechanics is the current theory that explains the micro. So you have the macro realm, which is everything above the atom. So with powerful electron microscopes, we can actually see the outside of atoms. And so our study, our observations, our science that deal uh, with the macro realm outside of the atom are pretty clear. I mean, we can throw a rock up and write math that takes a look at the trajectory of the rock, and we can predict it, and we can verify it. We can just run tests and just look. And so the macro realm is what some people think of as classical physics or Newtonian physics, and it's pretty testable, and our math is pretty good on it. Inside the atom, we're guessing. We do see things. We throw particles at atoms, and we do various experiments, and we do see things. And we don't really know what we're seeing yet. And that's where, as a natural philosopher, I kind of come in to the equation, is that I can interpret what all these very brilliant people are saying, and I can say, "Ooh, remember, that's just a speculative idea, no different than Valhalla or unicorn. It's until we see it, until we confirm it, it's just an idea." So think about it, talk about it, have fun with it, but that's all you're doing. It's not science. It's just speculation.
So you're saying that we're able to observe things in this you call it the micro realm. I mean, like we're looking at atoms with powerful electron microscopes. So we're able to see things, but we're not able to explain it because it doesn't match the physics or the math or anything that we expect from what we know of the macro realm, the bigger realm, like the Earth, and like throwing rocks or looking at planets, even that sort of thing. But so, how did I mean? Tell me about something that simple. Oh, well, you know what? I want to ask you about the thing that comes to mind to me is the thing called the slit experiment. So let's talk about that. Can you tell me what that is?
Yes, yes. Um, so one of the things we need to keep in mind is that when we talk about observation and seeing things, and that science is observation, what we're talking about is we're loosely talking about the word observation, right? Because most humans think of observation as I can see it, and that's not what we mean in science. In science, what we mean is that we can observe it in some way that is repeatable, that allows us to know its presence. So, for example, no one can see X-rays, yet we know through a tool that they exist. And so through a tool, we can see that X-rays and other things, microwaves, and just lots of things exist, but we don't see them directly. We have to use something like a telescope to see stars far away. That's not us directly seeing it. That's us magnifying it through a tool. And so these tools also mean just experiments or tests. So one of the things scientists say is they say things like observation is experiments and experiments is observation. So, for example, the first person to look up at the moon and say, that's the moon, participated in science. They labeled it, and then other people could come around and test it. Obviously, observation, direct observation like that is pretty straightforward. So in science, you might have biologists going out into the world. They might be looking for organisms around the world. And if they find a new butterfly, that's considered science. They have a discovery. They get to name it. That's science. That's observation. So it also includes experiments. So like when Galileo Galilei in the 1600s rolled bowling ball-like objects down slopes to measure the effect of different densities of balls, like a lead ball, a metal ball, a wood ball, that type of thing, and that they all rolled down the plank at the same rate. That experiment, that observation, told him something. And so what's happening with the micro realm inside the atom is scientists are doing bunches of experiments where they get to glimpse inside the atom and think about what's in there. So, through the history, we've learned various things. Like, I guess the first thing we learned is in 1897, we learned about electrons, that there was something inside the atom, that the atom wasn't indivisible. So it wasn't until 1897, just 130 years or so ago, that humanity understood that the atom was divisible. Prior to that, the atom was thought to be indivisible. It was a thing that there's no way to get inside of it, or anything like that. And so that discovery in 1897, through an experiment, he did an experiment. I think it's called like the gold foil experiment or something like that. But
Say that again.
It's like a I forget the name of it, to be honest with you.
Okay.
It's like a gold foil experiment where it proved the presence of electrons inside of the atom, and gave us a little bit of true understanding about electricity and electrons. And that's pertinent here to your question, only in the sense that it's kind of interesting to think about that prior to just 130 years ago, we thought the atom was it. And then starting about 130 years ago, we said, oh, wait, we can do this experiment here. Well, that proves that inside there's something. And so, and then we've just been doing experiments ever since then. There's a famous experiment called the double slit experiment. And that's what you're specifically asking about.
Yes.
That was actually conducted much earlier I think like in the 1810s or 1820s or 30s.
Wow.
We noticed that when you shine light at let's say a piece of cardboard with two slits in it, that it will cast a shadow on a wall behind it. And so people started wondering about that, and they started noticing different things about that, and that grew up into the double slit experiment, as it progressed. So we've done things like photons are massless particles. They have no mass. They're not physical, if you'll let me get away with that. And we were seeing that effect with that. And
okay, let me interrupt you a second here and just kind of recap this a little bit. So going back to 1810, so they had a double slit that they were just shining a light through, and there was a pattern that would appear on the wall behind it, and there were some observations about that. And then as these experiments progressed, now what you're talking about is that you're sending a single photon, massless particle, through these double slits, right?
Yeah.
Okay.
Yeah. So going back over 200 years, they sent these massless photons through there and observed some various things. And kind of on a parallel track with this, photons were thought to need a medium. So at this time, everybody thought outer space was filled with something called ether, because sound needs water or air or something to travel, right?
Right.
Sound, you can hear sound when you jump in a swimming pool, but it sounds different than when you're out of so sound does travel through that medium, but it needs the medium. And We thought light did too, but then in the late 1800s, around 1870s or so, we did some experiments that said that light did not need a medium, and so that changed physics there. Now, kind of at the same time, we started doing the double slit experiment and started doing the double slit experiment with electrons much later, in the early 1900s, and then with hydrogen atoms and helium atoms, and actually we see these various effects up to about 10,000 atoms, and the effect they're seeing has been known as, people may know it as like a wavicle or wave particle duality, or the collapse of reality inside of quantum mechanics, or they might know it as the splitting of reality into the multiverse or many worlds interpretation. They might know it as stuff like that. And we do see that effect. We observe it at with these experiments, and people are just trying to figure out what the heck it is.
Okay, Michael. So, Michael, you said wave particle duality. Okay, I want to hear, what is that?
Okay, so this is an effect that we see in the micro realm, and we were kind of trying to interpret it and figure out what it means. So in our macro world, we do see the effect as well. So, for example, when you throw two rocks into a pond, like you throw one rock into a pond, it hits the water, and from that entry point, you have waves that come out, right? So that's waves. And so we all know what waves are. The ocean has waves. There are sound waves that travel through mediums and like that. But remember, light, we've now determined light doesn't need a medium. So then people started asking, well, is it a wave then? Or is it something else? And the best words we've come up with so far is that we call it that it is both a wave and a particle. Sometimes people call it a wavicle. It kind of a nod to we just don't know, is what that's basically saying. And so if you think about when you throw two rocks into a pond, they both splash, they both make circles that come out, and then the circles start hitting each other. If you can visualize in your mind right now, two waves of in the pond kind of coming together, they don't clash and then bounce off each other. They kind of mix in and they form like a new pattern, and it's like a wave pattern. So the wave pattern is not like a particle, it's a wave, it has multiple things. So in the double slit experiment, the way that and this is, I wish we had like little graphics we could just show it, but let me just try to say this. So when you have so picture a wall with two holes in it, two slits, and you can picture them being pretty big, like 8 inches by 20 inches. And you take a BB gun and you start shooting at those two holes. And then what you'll see is, there'll be a bunch of stuff that bounce off the walls because you missed, right? Mm-hmm. But as you're shooting these, what you see behind the wall is just two lines, right? You see two lines of where the BBs went through and hit the other wall.
So basically, you're expecting that as you're just shooting at it, that the pattern on the wall is going to look just like the two slits. Because you're just going straight through those slits and creating it's like a mask that you're creating a pattern on the other side with the BBs, right?
Yes. Yeah. And so so that's what you expect, right? You just shoot these BBs at these, you take a machine gun, BB gun, and you shoot it in the direction of these two slits. And what happened? And on the back, you get a bunch of holes or dents in the wall behind it, just in two slits. But what we see at times with these experiments is we see not two slits back there, but like 6 or 7, and almost like if you take a wave and you push a wave through two slits like that, what it does is the wave turns into two waves, and the two waves collide and then turn into 4, 8, 16, and like that. So you end up with like a bunch of patterns, a bunch of slits on the back wall. It's very hard to describe this just with audio, but that's what the wave effect is that the wave effect has a bunch of slits on the wall. And so what we're seeing is Now here's where the weirdness comes into play.
Okay, let's hear it.
Let me stop there. Does that so far, did we describe the particle behavior versus wave behavior well enough?
I think so for the time being. Of course, I don't know what the audience member who's listening to this right now will think, but I think, okay, let's go ahead to the next thing, the weird part that you want to talk about.
Yeah. So what physicists are saying, and this sounds really weird, but it is proven. Now, our interpretations of what those mean are pure speculation. They're just guesses. But what they're saying is that light behaves like a wave when not observed, meaning the indentations or the pattern on the back wall. There's 7, 8 different slits back there, kind of like how light does weird things.
Yeah.
And they're seeing that, but when they try to watch a specific photon go through one of the 2 slits, so they set up an experiment, very advanced, where they actually watch for a single photon, if you will, for the sake of explanation, go through the slit. It behaves like a particle, meaning the wave pattern on the wall goes away, and now we have only 2 slots. And the only difference is we're now looking.
Okay, this is it. That is the thing that has made people crazy and has talk about ripple effects. This little bit of science, this observation that has been made in this experiment has blown people's minds all over the place, and and this is one of the reasons I want to talk to you about it. It's just this is like the little seed, and there's more about this I want to get into that has philosophers, mystics, and got people who are think about these things that imagine a lot of different explanations for what is going on. But what you're saying, okay, just to recap, is that okay, if you're just looking at the wall, you're going to see what appears to be a wave pattern that's coming through the slit. So, light's a wave. But when you look at the slit itself and watch the photon or whatever go through, suddenly it's just one thing. It's a particle. It's just the BB going in a straight line. And the only difference, and I'm repeating you, but the only difference is what you're looking at. So it's just what the observer is paying attention to that has changed the outcome of the experiment. And so what is the possible explanations that have been talked about for this?
Okay, so what you just iterated was a kind of the leading or original interpretation of what we're seeing, that us looking at it caused it to cause the wave to collapse. And so you'll hear physicists talking a lot about their ideas about why the wave collapses. And that's specifically, well, all they're basically saying is, oh, I have an idea about what we're looking at. And so one of the ideas is that, and that leads to some very strange things that people say, things like the photon is conscious and it knows that we're looking at it, therefore it chooses a path, and just weird things like that that they are honestly saying that it feels like that to me, kind of a thing. And those ideas feel a little bit out there, but remember, all they're trying to do is come up with an analogy that explains what and so we're trying out various things. And one of them, of course, is that what we're seeing is actual, that when we look at the photon, that we are seeing that photon do that. And what we're seeing is a split in reality, where actually the wave pattern is still there. It's just we're not seeing it now, and that this randomness is a split in reality. Now, from my viewpoint, I would say right up front, and I wish physicists would do this, I wish they would just stop right there every time they get to this point and say, and by the way, this is just a speculative idea. It's just a way of thinking about it. We don't know what we're looking at. We just don't. Now,
hang on a second, Michael, but I think on what you just explained there, I think you hinted at the multiverse idea. Is that what is that, am I wrong there, or is that right?
No, no, you're right. In sci-fi world, it's known as the multiverse. In the physics, it's known as the many worlds interpretation.
Okay.
Same difference. But in the many worlds interpretation in physics would be a little more nuanced and talk about why the experiment leads them to think that, hey, this kind of explains all this. Not sure exactly what it means, but it does explain it. The multiverse says, okay, assume that is true, and let's extrapolate from there and talk about what that would mean. And so that's the part that might be interesting to people, because it is a real possibility. I don't think it's necessarily going to be accurate, but I don't know. I'm not a physicist, but it is a possibility, and it is intriguing, because what it essentially is saying is that every random act that happens, the reality splits into two. And so they talk about infinite realities, and perhaps there are infinite realities, but what they're really talking about is each reality would split into two at each decision point. And that's where, like, Schrödinger's cat comes into play. People say, well, the cat is alive, it's dead. Well, it's both alive and dead until we look at it. And then once we look at it, we see one universe or the other. And then the debate is, but does the other universe actually still exist or not? And so that's kind of where all this talk leads us to.
Okay, yeah, there's a lot to unpack there. So,
Yeah.
okay, so you mentioned Schrödinger's cat. Now, the way I understand that thought experiment is that there's a cat in a box with poison. So tell me a little bit more. Yeah, you explain that thought experiment and make sure people know what that is.
All right. So now we're going back to the 1930s, and where the physicists are actually seeing this stuff. And so the way I write about it in 30 Philosophers is I talk about that there's, and I know physicists are going to be mad at me, but I talk about it in terms of the deterministic and sane camp of Albert Einstein, who says, no, God does not play dice with the universe, and there's no such thing as spooky action at a distance. And the physicists are saying, but Albert, we're seeing this. This is actually happening. And he looked and he said, you're right, it is happening. I can't explain it either, but I'm going to hold out. I'm going to stay in the camp of there's got to be a rational reason for this. There's got to be simpler than what you guys are saying. But that camp has kind of died out in a way. I mean, everybody's still debating it because we don't have an answer, of course. But for decades now, the camp that says, no, entanglement is real, the multiverse is likely real, all these things are likely real. So going back to 1930s and Schrödinger's cat, Schrödinger had to find a way to kind of explain this to the masses. And so he's trying to figure out, well, how do I talk about this in a way that people can understand what we're seeing? And so his thought experiment is you take a cat, you put it in a box, and you take a radioactive isotope and you put it in there. The isotope is going to kill the cat at some point. And but according to the randomness that we're seeing at the atomic level, we don't know exactly when that's going to be. And so there's a superposition at that point of the cat being both alive and dead. The way I like to write about it in my writings is I like to call superposition, I like to introduce the idea of potential. So potential goes all the way back to Aristotle. You know, an acorn has the potential to be an oak tree, but it doesn't have the potential to be a human.
Hang on a second, though. But
yeah.
Superposition, and in this experiment, Schrödinger's cat, this potential is actual. The variables in the potential is actual until revealed to be one thing or another. Like all the variables exist I mean, okay, right. Okay, you explain it, right? I'm trying to,
No.
wrap my
That's
head.
that's correct. Is superposition basically says talks about potential that okay, well, potentially the cat could be either alive or dead, because until it's dead, it's not dead, so it's alive, right? So when we open it up, we're going to see one or the other. So at this particular point, when the box is closed and we haven't looked, the cat is both alive and dead. And kind of the thing that's most people miss when they talk about Schrodinger's cat is what Schrödinger was saying is that, and in physics, what we think we're seeing is that the cat is both alive and dead right now inside the box. And that it's superposition is about the idea that particles exist in all possible states at once, meaning if it's possible for for the particle to be spinning one way and then the other, it's actually doing both right now, and we're simply observing one or the other. So when we look, we acknowledge that one or the other. That's the madness that they're trying to describe, and that's the madness that they're coming up with all these interpretations for, and they don't have answers for them, but it is real. We even have quantum computers that are based off of this stuff. We know it's real. It's just we don't know exactly what it means, or we don't know how to describe it, which, by the way, that's the history of science.
Well, yes, but you know what? Everything that you're saying so far, none of it veers away from the effect of the observer on the experiment. I mean, that there's a relationship, some sort. Maybe there's not an effect, but there's some kind of relationship between the person who opens the box and sees the cat, and 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 the cat itself and the thing itself, the reality or the whatever we're talking about, the possibilities. There's something going on there, and I think that that's the thing that just really eats at people's craw or tickles the imagination and all this sort of thing, is like trying to figure that weird thing out. And like you say, we still don't know what's going on, but so superposition. You talked about that a little bit. I think you mentioned entanglement in that somewhere. So.
Before we go on to entanglement, let me say one more thing
Sure.
about the observer, because it is true that in interviews like this, or when talking about this, it's one human talking to another human, so you get loosey-goosey with these terms and like that. Now, but I think if you hang on to the idea that an observer doesn't mean human, an observer just means an interaction, so that when two particles interact in our universe, we're seeing effects that indicate that maybe both possibilities are going to happen. So therefore, at every interaction, not just when you observe, but also every interaction that ever happens, you're playing pool and you have your cue ball and you're going to hit the 8 ball into the corner, and you go to hit it and it goes to and it hits the 8 ball, and all possible trajectories of it would happen at the same time. Now, in the macro realm, playing pool is pretty consistent. So consistent, you can become a pool shark. But in the micro realm, we're seeing that when that particle hits, it potentially could go, X number, all possible things, there's 2, 3, 4, whatever possible things it could go to. And the idea is that all of those occur, so the universe literally splits into 2, 3, 4 different things at that particular point. So I wanted to clarify that about observer. Observer doesn't really mean a conscious human being. It just means any interaction that happens in nature, which includes humans looking.
But I also want to go back a little bit. But that what you're talking about is that okay. So when you hit the cue ball and you hit the 8 ball in the micro world, every direction it could possibly go, it's going. I mean, but it's somehow all right. So an observer could be it could be an instrument that's measuring, not even a person, right? It could be anything, right? Or another particle it interacts with in some way.
Right. 'Cause remember what I started with. A observation is experiment, experiment is observation. So whether it's us observing or something else interacting, it's it's science.
Got it. So, okay, all right. This is a little bit mind blowing. Okay, I just want to digress here a little bit because there's one thing that kind of eats in my craw about so this idea of the superposition and the multiverse and all these things are possible at once. Like they had that Oscar-winning movie, Everything Everywhere All at Once. I mean that's one thing, but there's like tons and tons and tons of stories, science fiction. There's books, movies, series that use these ideas. They got the superposition where they're playing with reality in a way that there's all these different possibilities. Now, this is the part that really bugs me, and that is that everything is assuming and that there's another me over there, right? And that there could be an infinite number of me's. I mean, I guess if you're talking about infinite possibility, that's that. But the thing that doesn't logically follow in my mind is that if there's another reality that's on its own trajectory and it's been there, but you're saying that are you saying that these realities are constantly generated again, over and over? I mean, okay, all right.
Well, no. What I'm saying is that so the idea with the many worlds interpretation is that every interaction occurs. So given that premise, which is speculation, because remember, we don't know, but given that premise, because that's one possibility of what we're seeing, then what happens is every interaction that you have with this world. Now, we tend to think on the macro realm, like I decided to get married or I decided not to get married. And those are decisions, of course, but we're talking about interactions all the way down to, photons and electrons and like that. So every one of those has splits off and all possibilities occur. And what you are experiencing is simply one of those paths, meaning you are going through your life and everything that happens gets split off into millions or hundreds or dozens, whatever it is ends up being. I don't think any, but that's the theory, is that as you go through life, all things are happening all at once, but you're only experiencing one of them. And I have a good analogy for that if you'd like me to throw that in.
Yeah.
Okay, so one of the ways that, and I wish I could remember their names so I could give them credit, but one of the ways that kind of brings that idea a little bit down to earth is that when you walk into your living room and you turn on your radio, you are tuned into a particular channel. And when you turn the knob, you tune into a different channel. And so, but all those channels are in your living room at the same time, right?
Okay.
So, you're simply tuning one to the other. And so your existence, you and me talking right now, is one of the channels that we can tune into, and all the others are just vibrating on different frequencies. So we experience the one that we're tuned into, not the others.
Okay, right. Now, I just want to reiterate right now that what we're talking about here at this point is speculation that's based on science observations. This whole multiverse thing, but the serious people are considering all of this, and but one of the things that I hear about, I mean, the people talk about like in the, I don't know, like self-help, mystical realm or whatever, that this thing called quantum jumping. And so people are talking about, like in Everything Everywhere All at Once, they say that they can find another self in another, possible realm that knows how to play like Mozart. And that if they can tap into that, jump into that, then they can bring that talent back into where they are in this world. So people are using this now. So if people are having success with, making these kind of, efforts with their intention, I mean, who knows what the explanation is for that? But that's the basis of what they say that they're doing. So it's, but the reason I bring it up is that they're talking about this as like, oh, well, we know this is real because quantum mechanics, quantum physics has shown us, and blah blah blah. So anyway, I'm just throwing this out there, how it's affecting the way we think about reality.
Yeah. So one of the things I like to talk about at this point is that it is very true that there are serious people considering this. I mean, Max Tegmark, Stephen Hawking flirted with it, Sean Carroll. These are real physicists who, some of them absolutely believe the multiverse is real and talk about it in the same way that people talk about anything that they believe, like people who follow astrology. I don't believe in astrology myself, but people who believe in astrology, the way they talk about it is like, no, you do this and then that happens and then this happens. That's how these serious people actually talk about the multiverse idea. And so there are people that actually believe fully in it. Now, now you mentioned quantum jumping.
Yes.
And the idea, so
I know,
gosh.
right? Go ahead, right? I mean, I know that's a misinterpretation, I think, of what quantum jumping means,
Yeah.
but right, go ahead.
Yeah, but I got a fun one for you. This is something I haven't really told anybody before, but it's an idea that I'm flirting with myself. Just thinking about, I'm not a physicist, but I love thinking about ideas. So one of the things that's going on is that we see this weirdness in the quantum realm. We see things like entangled particles are entangled, connected, and they do something based on the other one when you look at it and like that. And they're as far apart as 700 miles is the furthest I know of, at least. And these weird things that happen. And so now deterministic scientists come along and say things like, okay, so that's happening in the micro realm, and then it stops at about 10,000 atoms. So when you start doing particles at about 10,000 atoms, the wave collapsing is no longer being observed. And somewhere between 10,000 and 100,000 atoms, somewhere in there. It's no longer being observed, and we're in our Newtonian classical world where things work the way we say they work. However, I do see a lot of parallels, like, my parents died, 10 years ago, but I'm still entangled with them. I still think about them. They still have an effect on me, even though they died 10 years ago. And every one of these things, so real life is real messy, just like the quantum realm. And it's hard to apply science to it, just like it's hard to apply science to the micro realm inside of the atom. So there might be something there. I don't think we've discovered it yet. I don't think any of the ideas out there give us a unified theory between what we're seeing in the micro and the macro. I don't think any of them. I think sometime in the future, I mean, it could be next week, but if I was to predict as a futurist, I would probably say that we're at least hundreds, maybe thousands of years away from coming up with a unified analogy that describes all of this. Maybe it'll come sooner, but my point is that there's something that deals with the properties of something like a wave that collapses that we also see in real life. And there is a correlation there. So
okay.
that reality that life is messy, the quantum realm is messy, science is clean. What sci-fi writers are simply doing is saying, all right, well, we know it's messy. How big of a stretch is it to take this one idea here and bring it over to here? So, for example, with quantum tunneling, not quantum tunneling, the jumping, quantum jumping is about what we're seeing inside of an atom is electrons jump from one shell to the other. Not slide, they don't like move, they don't fly from one shell to the other, they jump instantaneously, almost like they're going through another dimension or something. But that's speculation. We don't know what that exactly means. All we know is that what we see it jumping. So if you take that concept and you bring it to our macro world as a science fiction writer, how big of a stretch is it to say, well, what if there are somebody out there can figure that out? So, there are sci-fi movies that and shows that talk about a physicist who figures out how to bring that craziness into our macro realm, and then they can jump into another reality and switch places, drug their doppelganger and drag them back to their universe and fly back jump back into this universe, that type of a thing. And it's an extreme stretch, but I'm telling you, there is something between the micro realm inside of an atom and real life that is intriguing, and science kind of sits in the middle of that, talking about its reproducible observations.
Okay, so but yeah, I want to recap what you said is precisely about quantum jumping. Is that okay? So are we talking about, what did you call it? An atom in a shell? Is that right? So it's in
electron shifting energy levels is what physicists are seeing.
Okay, an electron shifting energy levels, but it does it like it's like instantaneously. It's like first it's here and then it's there. There's like no observable movement except for it disappeared and appeared there instantly.
Yeah.
Right.
They don't slide, they jump. And so if you think about Bohr's original 1923, I think it is, picture of the atom where it's just like a nucleus with circles around it.
Yeah.
And circle represent an electron orbiting. What we're saying is that electrons don't slide to the next shell. They just appear in the next shell magically.
Wow.
And so what does that mean magically? Is it through another dimension? Is there something we don't know? I mean, it could mean lots of different things. Just because we don't know something doesn't mean anything. Science is about discovering and observing and discovering and trying to figure out what we're looking at. And the word magic can't be a part of it.
Well, right, exactly. So I mean, it's, what do they say? I mean, magic is just science you haven't figured out yet, sort of thing. So
Yeah.
right. So now I'm going to talk a little bit more about entanglement. We've thrown that around a little bit, and you said it's a. So let's get into the specifics. Simply put, what is entanglement?
So entanglement is something that physicists started observing, I think, in the 1920s, and Einstein, and that. So there were two camps that said, "No, you're not seeing that," and then the other physicists that said, "Yes, we are." So Bohr and very famous physicists said, "Yeah, we are seeing these, and it is real." And then in 1935, Einstein, Podolsky, and Rosen, came up with wrote an article that they published that said, entanglement does not exist. That's spooky action at a distance. God does not play dice with the universe. You are wrong. And we're going to prove it. And if you think it's right, then then this would be true. And that's just not true. And then we spent the next 30 or 40 years figuring out the spookiness was absolutely correct. And we are seeing the weirdness. And so Einstein, Podolsky, and Rosen tried to disprove quantum mechanics and ended up, in a way, proving it or confirming it to a degree. And so entanglement is the idea that, you can, physicists have a way to take two particles that are spinning, let's say one left and one right, and entangle them together. And then once entangled, they can carry them off and do experiments with them. So, whether it's the experiments confirm so far that whether you take them apart, a few inches or a few miles, and I think this has been done up to about over 700 miles. When you observe one and change its spin, the other one does exactly what the opposite of it. So they're correlated, and so they're entangled spookily, almost. Now this is where I usually like to talk about string theory, because string theory kind of enters it kind of from a conceptual point of view, right? So from a conceptual point of view, it's almost like those two particles are connected by a string through other dimensions, perhaps 10, 11, or 26 of them. And through those dimensions, the string is what's connecting them. So it's not spooky action at a distance. It's not magic. It's string theory. And so here's all the math that proves it. And so that's what string theory imagines, is that there's a string and these particles are, in essence, the tips, if you will, of the strings in our reality, in our four-dimensional, three-spatial, one-temporal reality in space-time. We see these tips of the strings that actually exist in other dimensions.
Okay, so you're still looking at one object then. So what you're saying, but you're looking at the same object at two different points, at two ends of the string.
Yeah. I mean, that's in essence, that's what. Now, remember, these are analogies, and remember, language is imprecise and can never describe reality because it's not reality itself.
No, right.
So what we're saying is we're coming up with an analogy.
I'm sorry, Michael. Can you say that again? You cut out a little bit.
Sorry. So string theory is not the reality itself. Physicists, when they talk about string theory, aren't saying there are actually strings that go through other dimensions. What they're saying is that we believe we can come up with math that describes something that's like strings going through other dimensions and can predict things in our world reliably. The problem is they haven't been able to do that last part correct, predict things in our world reliably. And but when they talk about string theory, that's an analogy, something that we can hold on to as humans, and then what it ends up becoming later on, if somebody comes up with a better analogy, fine. But the only thing that humans can do is we can only imagine what's in our own universe. We can't ever, we know, you do you know what a tesseract is? It's that four spatial dimension square box.
Yeah.
We know what a shadow of it looks like in ours, but we can never really picture what it looks like because we're in the three-dimensional world. But yet we can have a shadow that describes it accurately. And so does that mean anything? We don't know yet. But the idea is that string theory is a set of mathematical formulas that are attempting to explain everything, macro and micro, that we are seeing. And so far, it hasn't panned out.
Well, I see, because still there's so much that we can't observe to even measure, right? But now, to stay with entanglement, when I first heard about this, the first thing I thought was like, oh, wow, what if somebody could use that for communication? Because because everything we use for, communication these days, it's all about radio, which is like light. I mean, and you have the speed of light, and then you've got, you can't like send, radio signals to the other side of the moon, for instance, that kind of thing. You got line of sight problems. And I was thinking, oh, with entanglement though, can you get these particles to communicate like anywhere? And the other thing to understand, tell me if I'm wrong, is that the corresponding influence on one particle to the other is instant regardless of distance. I mean, there isn't like a speed of light, regulation on that. So it happens instantly. So I'm thinking like, oh, wow, wouldn't this be fantastic? Because I mean, obviously in all the science fiction, everybody's like, communicating between, planets that are light years apart, and they're talking to each other in real time. Like that's not even possible as far as we know. But with something like this, maybe. And then I read that the Chinese had actually developed a satellite using entanglement, and it's like they're using it for encryption, like end to end. It's like there's no way that anybody can listen to their communications. But I'm thinking like, hey, somebody's actually doing it. What do you think about that?
Well, I guess what you said was maybe, and so in philosophy, if you're a natural philosopher like me and you are pursuing truth, I'll go along with maybe.
Right.
But they haven't. They can't use it. They can't use entanglement to communicate because they don't have control over what the other does, and at least not yet. And so we haven't really done that yet. But theoretically, as an idea, yeah, I mean, I think neither one of us would be surprised if 20 years from now, there's a thing called an entanglement radio that instantaneously allows you to communicate. So if you take one on to the other side of the moon or anywhere in the universe, you can talk to the other person instantly. Yeah, I that does sound interesting. So maybe is about the best I'll do on that.
Okay, yeah. I mean, good. We're in the maybe camp on that. I mean, that is like logically possible. I'm thinking, well, who knows, right? What are we talking about here? So yeah, we've covered a lot today. But I think that what I want to sort of get an overall picture, get your impression, like you as a natural philosopher. I mean, you're looking at these, the science of what is known about this, micro realm. You got the macro realm, which is, pretty much follows the math. So,
Sure.
but then when it gets small, it just turns into mush. You kind of like there's a lot happening that you can't see, and things you do see, there's no explanation for it. So what is that? I'm asking you. So how does that affect the way you think about reality at large? I mean, like, and I know that we don't have a scientific, unified theory of everything, but are you working on a philosophical theory of unifying? Do you get my point? What I'm saying?
Yeah, I do. And, my mantra includes following truth or seeking truth. And so I'm always trying to determine what is truth. And observation is repeatable. So I guess one definition of truth could be science, could be, observation. I do see, for me, I'm kind of just following it myself. Maybe what I'll do right now is let me just ground anybody who's lasted this long in this podcast. Let me just ground everybody's mind in what we do know and what the central debate is about. So we see 17 particles. And 4 forces. So the particles are things like electrons and neutrons and protons and quarks and all those muons and all those things that we all know, or that we hear about. And those particles, physicists are trying to figure out, they're kind of an analogy. They don't really exist as particles, so there's no such thing as an electron or a proton or a neutron or a photon. Those are just analogies that are used for the human mind, just to make things easier. Some of them are probably a little bit more like a particle than others, but for example, out of the 4 forces, now the forces are things that act on each other from a distance, right? It's like gravity instantaneously acts on another object an infinite distance from you. That's the Newtonian view. The Einstein view is that gravity doesn't exist at all as a force, and it's simply the fabric of space and time. And so with Newtonian physics, we went from 17 particles and 4 known forces to quantum mechanics, where we have 17 or maybe 18 particles, depending on whether we discover the graviton and prove it. And that would mean that we have 3 forces, not 4. And so, because gravity is one of the 4 forces. So if we're going to say gravity is something else, then that's the thing that needs to be redefined. So modern physics is a debate about gravity. about what is it? Is it one of the particles, or does it fit in the analogy of particles? Does it need a force carrier to carry it, or not? And so one of the things I like to say about gravity that I think grounds it a little bit is imagine somehow the sun disappeared right now, just like that. It's gone. According to Newton, we would feel the effects of gravity immediately. And according to Einstein, we'd feel it 9 minutes later when the effects of light, gravity, and everything got to us.
Oh.
And so the distinction there is that Newton felt gravity was a force that had instantaneous effect on other objects. And Einstein said, no, it's more like the fabric of space. And it turns out Einstein was absolutely correct. We know now that if the sun disappeared right now, everything would be hunky-dory for us for another 8 or 9 minutes. And then all of a sudden the sun would disappear and we'd start drifting off in a straight line or a trajectory not around the sun because it's no longer there.
And that would be big uh-oh. Yes.
Yeah, so that's the nature of what they're looking at. My opinion is that that the better we understand that these are analogies, the better off we'll be. My opinion is that the better we understand what ideas are pure speculation and what are observations is good, because if we have that understanding, then we can listen to people like Roger Penrose, who's brilliant, but most physicists will present ideas and they will say the right words. It's just I don't think people hear them. They'll say things like, "Oh, the idea of this person here is about is this," and then they'll go into this weird idea, presenting it very eloquently as if all of it is true. When if the interviewer would stop and say, "Oh, by the way, do you think any of that's true?" And Roger Penrose would say, "Oh, no, I don't know. I'm just telling you what they said, what they think." And is it a possibility? Yeah, I guess it's a possibility, but they never do that part of it in interviews. They just present it. So most people who listen to physics tune out because it just sounds like gobbledygook. One of the articles I wrote and put on Touchstone Truth was something about understanding the gobbledygook of physics, because it is clear, the observations are clear, the gobbledygook is gobbledygook. It's just stuff that's interesting, we can follow it, but until any one of them are proven, it's just talk. The big rip, the big crunch, the universe ending in cold, trillions and trillions of years from now. My idea of the island of islands, which is just a dumb speculative idea like all the others. They're just ideas out there that are interesting to think about.
I get, and of course we need these ideas because otherwise, we need some sort of, way of, I'm looking for something gets us out there, making experiments. It's like, okay, what if this is true? And then, oftentimes we discover something we weren't looking for, but at least it gives us, and some motivation to keep looking for things, right?
Yeah, and just if I could say about that real quickly, yeah. So in my idea of ideas, there are empirical ideas, which are observations. There are rational ideas, which are indirect ideas about those direct observations. And then there's irrational ideas. In irrational ideas, there are disproven ones. And I'm sorry for people in your audience that will hate me for this, but there are disproven ideas like the predictive abilities of astrology. It's absolutely proven that the predictive abilities of astrology are no greater than
No, say that again. No greater than what?
random chance.
Okay.
And there are, and then there are new ideas. And the new ideas end up falling into currently unknown and the unknowable. So there are ideas out there that are just unknowable, but there are unknown ideas that we will figure out eventually. And all ideas start out as speculation. All of them.
All of them.
No matter what. All start out as speculation.
While you're talking about this, and I struggle with this myself. what I mean by, this whole thing of, figuring out what is true. Now, we've been talking about science this whole time, but the thing that that is difficult, is almost impossible to prove, is personal experience, right? And personal experience is where most mysticism, or just about all mysticism, kind of, lies. It's in, like, I experienced this. I mean, I have no other way of measuring reality than my own experience, right? I mean, no real concrete way. And if I can, and I'm sure that I experienced something, and then it happens again, and then I try something different, but I'm not able to really share all that with others, but it's happening in me or my perception. You get into a gray area, and I think that this is, for me personally, has been, struggle in my life, because I'm one of these people that have these experiences that, it's like not easy to talk about with other people, and I'm looking for explanations, right? So the mysticism may have that, and you maybe talk to other people. But the reason I'm bringing it up is like science obviously, it does a great job, and psychology too has doing a great job of mapping behavior in people, and in different patterns of behavior. But you, as a natural philosopher, how do you fit in a person's individual experience in a search for truth?
Well, that was a lot to unpack there.
Oh yeah, right. Okay.
So first off, when it comes to personal experience that becomes part of your worldview, you're a human, and you also have reason and logic and critical thinking. So you can decide how much of that you want in your life. And so through critical thinking, through logic and reason, you can weed through the weeds. You can get through the weeds. But as far as human experience goes, that is life. Experience is life. There's in 30 Philosophers, one of the themes of the book is I talk about the concept of impressions that humans go through, and the evolution of that over the last 5,000 years, and how we all learn by our experience. And so, for example, humans are born a blank slate. If you believe in a soul and heaven and all that, then you're born with a soul, and or somewhere around your birth, God or somebody put that soul into your body, and but you're a blank slate nonetheless. And so at that point, if a Bengal tiger came up to you and roared in your face, you wouldn't know to be scared of it, because, well, there's the noise. We have an instinct about noise. So if it roared, you'd probably be scared. But if a Bengal tiger carefully came up to you as a newborn, you wouldn't know that you're in immediate danger. You haven't learned that yet.
Right.
And we learn by impressions. We learn by seeing our parents and connecting with them and bonding to them. And there's some instincts in there that deal with that. And so that's how humans learn. And, whether it's, well, I was going to talk about a little bit of history there. I'll skip that. But the impressions, but we do learn by impressions. And so your reality is the only thing you know.
Right.
You don't know anything else. Somebody born in Iran knows that culture. We know our culture. I mean, one of the things that I've been writing about lately is the idea of the Fermi paradox, and the idea that aliens haven't visited us, therefore they probably don't exist, kind of a thing. And I think it's just such a ridiculous thing to conclude with. It's a fun framework. I'm not saying the Fermi paradox is stupid. I'm not saying that. I'm just saying that the Fermi paradox tends to be way too anthropomorphic to be when it's generally talked about with people. And so, if you think about just humans on Earth in our time and how we think and what we do, if you could magically go back 50 years, even here in America, right here in California, or to New York City maybe, or whatever, it would be so different. The things that come out of people's mouths, you'd be like, whoa, why is that person saying stuff like that? Let alone humans that were in England 200 years ago or in Egypt 600 years ago. And like that, the experience that humans have with the culture that they grew up in is who they are. I mean, that is their worldview, and there is no way to get around that. And that, and so yeah, so your experience is you. I mean, that is your life. Your experiences are your life, and how you embrace them and what you choose to do with that is the freedom of being human.
I love that. Okay, Michael, this has been a wonderful, I love this conversation. And you know what? I would love to do this all day, but anyway, so Michael, it's been great to have you today. And again, I'm probably going to have you on again because you're such a great conversationalist, and I love the back and forth with the ideas. And I love that you come on and you can talk to me about these things and get it down to what do we really know about these things, and that's what I love you to you're able to call me out on those stuff.
Thanks, appreciate it.
Yeah, you are welcome. Okay, and that is all for this episode of Audible River. And wherever you are on this wonderful planet, we would love to know what you think about our podcast. So please leave a comment or email us at audibleriverpodcast@gmail.com. Thank you for listening.